In this video, we will move one step further and make a regression model that would look at the combined effect of the 4 predictors on the response variable. In the combined model, we could possibly get a different result compared to the one we got through individual analysis. In other words, some of the variables that were discarded in the individual analysis might become relevant in the combined analysis. Let's move to R. In R, the way to write code for multiple linear regression requires the use of lm function. In brackets, we first have the name of the response variable, followed by the tilde sign, and then we have the name of the predictor variables separated by the plus sign. The second argument in the lm function is the name of the R object where the data containing the variables is stored. The output of the model is stored in an R object which we have named call mode. Let's go through the result of the multiple linear regression using the summary function. As you can see, this time the results are a bit different, with 2 more variables, namely total and college jobs, becoming significant based on the probability value of slope. If you recall, on the basis of the last video, where we have done simple linear regression using the same variables, only shear percent was significant. In the combined model, apart from the shear percent variable, 2 more variables, that is total and college jobs, have also become significant. The 4th variable, that is unemployment rate, is still insignificant, with the probability value of slope being 0.07 or 7.6%. The value of R square is 0.4264 or 42.64%, which means that the combined model reduced the total error in the response variable by almost 42%. Now, we should remove the insignificant variable, that is unemployment rate, and remake the model. I have stored the output of the second model in the same R object that we have named call mode. If you go through the summary function, the result is almost same with regards to the PR value of the predictors, and the value of R square has marginally come down by 2%. Let's see how to understand the 3 slope values. Slope value for the variable total is minus 5.6 e minus 0.2. The predictor variable total is the absolute number of students in each field. The response variable median is the median income of students in US dollars. So since slope is the change in response variable caused by a unit change in predictor variable, and the slope value we have is minus 5.6 e minus 0.2, we can say that a unit increase in the number of students in a field would bring down the median income by $0.05. Minus sign here indicates that there is a negative relation between the predictor and the response. Remember, minus 5.6 e minus 0.2 can also be rewritten as minus 0.05694. If we multiply both predictor and response with 1000, we can say that 1000 unit increase in the number of students in a field would bring down the median income by $56. You see, what we have done here is that we multiplied both response and predictor with 1000. So minus 0.05694 multiplied by 1000 is 56.94, and the predictor 1 multiplied by 1000 would give us 1000. Let's think of a possible reason of the reduction in the response variable median because of increase in the predictor variable total. In other words, why there is a decrease in income of the student because of the increase in number of students in a field. Increase in the number of students in the field suggests easy admission and less entry barrier to a course, thereby causing a supply surplus, which will definitely cause a dip in median income. Now let's examine the second slope value corresponding to the predictor variable shear percent. The unit for shear percentage, that is percentage of female in a field, is percentage, and the slope value we have is minus 3.198 e plus 0.2. This slope value can be rewritten as minus 319.8. So we can say that a 1 unit increase, that is 1% increase in the percentage of female in a field, would bring down the median income by $319.8. The same way E followed by a minus sign would imply that we need to move on the left side of the decimal, E followed by a positive sign implies that we need to move on the right side of the decimal. So, minus 3.198E plus 02 implies that we need to move 2 positions to the right of the decimal, thereby making the value minus 319.8. What could be the possible reason for decrease in median income with increase in the number of women in a field? Although we can't really pinpoint the real reason because all we have with us are numbers, but some of the possible factors could be gender discrimination or poor course choice among females. Third slope value for the predictor college jobs is 1.609E minus 01, which can be rewritten as 0.1609. The variable college jobs is absolute number of students who got job in the same field in which they have studied. So based on the slope value, we can say that a 1 unit increase in the number of students with jobs in the same field would increase the median income by $0.1609. In other words, an increase of 1000 in the number of the students who got jobs in the same field would increase the median salary by $1,609. What could be the possible reason for increase in median income due to increase in the number of students working in related field? If the students are not forced to work in different fields other than their own, it means that there is enough demand in their own fields, thereby resulting in more income. To summarize, you can see that different combination of predictor variable could change the regression results. It is therefore advised to make several regression models and compare the outcomes from the previous models. Finally, you should use the one that you think makes the most sense.